I'd like to thank you for attending the next series of our workshop. It's entitled Manage and Track Applications and Infrastructure Configuration Changes Using AWS Config. My name is Isaiah Salinas. I'm a Senior Specialist Solution Architect for the Cloud Management Services here in AWS. Today, we're going to talk about some of the challenges that many have faced when managing and tracking compliance changes within our AWS resources. We're going to go over as far as what are the 3 lines of defense and how can this help us in managing and tracking compliance. We're then going to talk about the AWS services that can enable one to track and manage their configuration changes and keep in a specific compliance state. Then lastly, we're going to go over a demo on how we can utilize AWS Config to help manage and track our AWS resources to run operational excellent workloads within our AWS environment. So first, many customers tend to ask themselves, which service do I use to help me with my compliance? Which AWS service can I use to help me manage and track my configuration changes? We have a wide range of AWS services, but which one can help us manage and track our workloads within AWS? To help us understand this, we're going to go through what the Institute of Internal Audit provides us a guidance called the 3 lines of defense. As per this model, the business unit, frontline function, implementers, own and manage risk compliance. This is called our first line of defense, called manage risk. Our second line are the control functions that set the guardrails and controls and oversee that risk and compliance are being effectively managed. This is our second line, oversee risk. Finally, the third line, assurance of risk and management, are the functions that provide independent assurance as to the effectiveness of the risk management and compliance. We have mapped the AWS suite to these 3 lines of defense model as a quick reference of the service capability fits with some overlap. The 2 use cases that we will drill down more in the following slide has also been mapped to the 3 lines of defense model. The first line, manage risk. These include AWS CloudTrail, AWS Config, AWS Control Tower, and AWS License Manager to help customers to implement operational controls of their cloud resources. The second line, oversee risk, include Amazon CloudWatch and AWS Security Hub to help customers to gain a comprehensive overview of operational health and security posture across their AWS accounts. Our third line, assurance of risk management, includes Audit Manager to help customers to assess their controls for security, change management, software licensing, and business continuity. Let's take a look on 2 specific services that can help us in the manage risk, that can help us in our operational excellent workloads. The first one is AWS Config. At the core of these set of services that can help you enable compliance and monitoring is one of our key detective control platforms, AWS Config. What is AWS Config? AWS Config is a service that enables you to assess, audit, and evaluate the configurations of your AWS resources automatically. AWS Config allows you to automate the evaluation of recorded configuration against desired configuration using features called AWS Config rules. For example, let's say you want to make sure that all S3 buckets created are encrypted. You can deploy an AWS Config manage rule that automatically evaluates that resource right at the moment it is created or modified. We provide a rich set of rules that evaluate some of the most common scenarios. Those are called managed rules since they are provided and managed by AWS. But you also have the ability of creating your own custom rules powered by the AWS Lambda platform. Utilizing AWS Config can help you manage and track your configuration changes on your AWS infrastructure. Another service that can help with managing your operational excellent workloads is AWS Systems Manager. AWS System Manager is the operation hub for AWS resources. It allows you to group resources in a way that is meaningful for your operation teams. It then provides you with rich visualization that helps simplify operation. Lastly, it allows you to take action on those resources by providing tools to automate workflows and EC2 instance management. But it also plays an important role in enabling compliance and monitoring within AWS. How so? AWS Systems Manager Automation allows you to create automation workflows to manage AWS resources. You can design remediation actions to fix non-compliant resources detected by AWS Config. Automation provides a simple-to-use control experience to create automation workflows. You can also use our DSL to write your own Python or PowerShell script to run. The run command is also another feature. AWS Systems Manager run command lets you remotely and securely manage the configuration of your managed instance. Run command enables you to automate common administrative tasks and perform ad hoc configuration changes at scale. You can use run command with configuration management tools like Ansible, Chef, and even Chef Inspect. You can set the compliance state of EC2 instances based on configuration management execution results. This data is rolled up into AWS Config to provide you a centralized control of your compliance states. We're now going to go over a demo on how we can utilize AWS Config to manage and track our infrastructure resource changes within our AWS environment. Let's go through this demo. So to begin our demo, we first want to deploy some prerequisites that AWS Config will use within our demo. And these are some IAM roles that we're going to set up that we're later going to use when discussing a little bit about conformance packs. So to start off with, we'll go ahead and use the CloudFormation template that was provided for this workshop, and we'll go ahead and deploy that by going over to CloudFormation. And we're going to go ahead and click Create Stack. We're going to upload the template. Choose File. Select the template, which is our workshop config prerequisites. And I go to select the name there. We'll click Next. We'll then give it the name, Workshop Config Prerequisites, and we'll click Next. We'll keep all the defaults, scroll down, and we'll click Next. We'll scroll down to the very bottom, and last, we want to go ahead and select the checkbox that I acknowledge that AWS CloudFormation might create IAM resources with custom names. We'll go ahead and click Create Stack. This will then deploy the resources needed for our various labs we'll run within this workshop. So we'll let the CloudFormation template go ahead and deploy. While it's deploying, we'll go over to AWS Config. And now we're going to go ahead and enable AWS Config to start tracking and recording resource changes within our account, within our region, within our AWS account. So to set up AWS Config, we'll go ahead and click Get Started. And this is going to set up the AWS Config Recorder. And now what the AWS Config Recorder does, it allows us to allow AWS Config to now start tracking and recording AWS resources that are supported with AWS Config for any configuration changes or new resources being created. Under the configuration of the recorder, you are presented with two options. You can record all resources supported in this region, or you can specify specific resource types. Now, AWS Config is a regional service, so you will need to enable AWS Config in every region you want to track and manage resource changes within your AWS infrastructure. A good best practice is to allow AWS Config Recorder to record all resources supported within this region. This will allow you greater flexibility when coming to enabling AWS Config rules to evaluate resource changes. It'll also will allow you to include any new AWS resources that are currently supported within Config. The next option within our Config Recorder is the option to include global resources. This would be AWS services such as IAM resources. We want to go ahead and have this enabled because we also want to track IAM resources that get created or modified. However, do keep in mind that when checking this box, you want to have this box checked for only one region within your AWS account that you have AWS Config enabled. And the reason this is that if you have this enabled in multiple regions, you will be getting duplicate resources that are recorded and tracked within AWS Config. Also doing duplicate, incurring additional charges for those duplicate resources. So definitely you want to only have this checked for one region within your account that you have AWS Config enabled. The next item is your AWS Config role. You have the option to use an existing AWS Config service link role, or you can choose an IAM role from your account. You can create an IAM role that includes the IAM policy defined within our AWS Config documentation that allows AWS Config to record and track resources within our account. For this exercise, we're going to go ahead and leave it the default as use an existing AWS Config service link role. The next option is our delivery method. As AWS Config tracks and records changes, it will then deliver those recorded changes over to an S3 bucket. Here's where we'll define where that S3 bucket will be. By default, we'll go ahead and create a new bucket with a bucket name. You also have the option to choose an existing bucket from your account, or also choose a bucket from another account. If you have AWS Config enabled in multiple regions and multiple accounts, then a good best practice would be to choose a bucket from another account. This could be a bucket that resides into a central logging account or a central compliance account where you're going to be keeping these configuration items in one central location. For this exercise, we're going to go ahead and leave it as the default in creating a bucket. And then we'll go ahead and click Next. It's then going to ask us to then choose some of the AWS managed rules. For this area right here, we're not going to select one. We'll later discuss AWS managed rules in the following. And we'll go ahead and click Next. It's then going to ask us to review our settings, and we'll go ahead and click Confirm. It's then going to enable AWS Config Recorder and enable AWS Config to start tracking and recording resource changes within our account. It's been successfully enabled, and now it'll take us back to our dashboard, where then we can now see AWS Config Recorder is now recording various AWS resources within our accounts. So now let's take a look back at our CloudFormation template to make sure it was deployed successfully. So we'll go back to CloudFormation. And we see our stack here, workshop, config prerequisites. And if it deployed correctly, we should see a create complete. So this lets us know that the resources were deployed that will be needed to utilize AWS Config for the various labs we're going to go through within our demo. So we'll go back over to config. Now with AWS Config, we have AWS Config rules. Now what AWS Config rules allows you to do is allows you to set up a rule that will then check a specific rule evaluation against your AWS resources to make sure it's at a desired configuration state. AWS Config has two types of rules. We have AWS Config manage rules and AWS Config custom rules. And to add a config rule, we'll go ahead and click on add rule. We then are presented with the two types of rules that AWS Config supports. AWS managed rules, we currently have about 171 AWS managed rules. These are config rules that are managed by AWS and that could cover a variety of different use cases. For an example, if you would like to utilize an AWS config rule to check on your configuration compliance state of EBS volumes, we could look up volumes. And one in particular is this one here, EC2 volume in use check. This will check whether an EBS volumes are attached to an EC2 instance. This particular rule will help us identify volumes that are currently not attached to an EC2 instance and mark them as non-compliant resources. This is helpful because it allows us to keep in track of our operational use of our EBS volumes. If there is a volume that's not currently attached, then we can take some action against that volume to perhaps see if it's needed and snapshot it to avoid any additional cost for unused volumes. Similarly, if we take a look at elastic IPs, so we'll type in elastic IPs here, there is another rule here that is called elastic IP attach. And this one checks whether all elastic IP addresses allocated to a VPC are attached to an EC2 instance. This is another good use of an AWS managed rule to help us identify specific AWS resources within our accounts that may be incurring additional costs if we're not using them. So we can actually use this managed rule to then mark any elastic IPs non-compliant if they're not currently attached to a specific EC2 instance or an ENI. If they are not, then we can then have the option to choose whether we want to release this IP to not incur additional charges. However, some other managed rules that we can look at for our operational uses is S3. So we look at S3 rules. We have a variety of S3 managed rules. Like for an example, some of our operational best practices with S3 is not to have S3's buckets publicly available, to have public access available on them. And we have some managed rules here that will help you keep that configuration state within AWS Config. Here we have one here called S3 account level public access block. This will check whether our if we're allowing public access at the account level. Additionally, there's a rule that checks at the bucket level as well to check if public access is prohibited. So these are some areas where we can utilize AWS config rules to keep our operational use at a desired configuration state to keep into compliance our workloads we're running within AWS. For this lab, we're going to go ahead and utilize one of the AWS config managed rules called restricted common ports. What this AWS managed config rule will allow us to check our security groups and make sure that it does not allow any public access for specific ports. This would be good because when we have our workloads running, and one of our operational best practice is not to have public access available on the internet for specific ports. So in order to keep this desired configuration state, we can utilize this rule, restricted common ports, to restrict specific TCP ports not being publicly accessible on the internet. So we're going to go ahead and select this rule, and we'll click Next. The next window is going to show us our configuration for this rule. Down below, we have the trigger type, which is set to when configuration changes. This is going to enable the evaluation of this config rule whenever AWS Config Recorder detects a change of a specific resource. In this case, it's monitoring EC2 security group resources. So it's going to trigger a rule evaluation whenever it sees a change for that resource. Down below, we have the parameters that this rule is checking. So this rule is by default checking these specific TCP ports. So in our example, in our lab here, we're going to also check port 22, which is our SSH port. So we're going to modify the first one here, the value, and change it to be port 22. We'll then go ahead and click Next. It'll ask us to review, and then click Add Rule. Our AWS Config rule is then deployed to AWS Config, in which we can see it here, restricted common ports. Now what we're going to do is we're now going to go ahead and deploy an EC2 instance with a security group that actually has SSH open publicly to the internet. So let's go over to our EC2 console. And we'll click on our instances. And we're going to click Launch Instances. For this lab, we're going to go ahead and choose Amazon Linux 2, AMI. We'll go ahead and select that. We're going to choose an instance size of T3 small, and then click Next. In this area, we're going to go ahead and then under IAM role, we're going to go ahead and choose the Workshop EC2 SSM role. This was an IAM role that was created by that CloudFormation stack we initially deployed. This IAM role will then allow it to communicate to SSM to further manage this instance. And later in the lab, we're going to see how this works together with remediation actions under our config rules. So we'll go ahead and select Workshop EC2 SSM role. We'll click Add Storage. We'll leave it to defaults and then click Add Tags. We'll leave that those defaults and then we'll click Next for Configure Security Group. So in this area here, we're then going to configure our security group. So we're going to go ahead and name our security group to be Workshop Security Group, and we'll do the same for the description. We can see here by default, it is enabling SSH port 22 publicly out to the internet. So we'll go ahead and click on, we'll leave it as that and click on Review and Launch. It'll ask us to review our configuration, and then we'll click on Launch. In this area here, we're going to go ahead and click down the drop-down box where it says choose an existing key pair, and we'll go ahead and select proceed without a key pair. We'll select the checkbox that says you acknowledge, and then we'll click Launch Instance. Our instance will then get deployed and launched, and we'll go ahead and click on View Instances. And our instance is still running and initializing. So now we'll go back over to AWS Config. Now in AWS Config, we'll go over to our rules. And we'll click on the rule we just previously created that's called Restricted Common Ports. Now this rule, since we deployed a new EC2 instance that had a new security group with the public access available for TCP port 22, which is one of the ports that we are checking within this rule. AWS Config will then evaluate the new resource. And then once it detects that it's out of compliant, it'll mark it here, the resource, and put it in a non-compliant state. Let's go ahead and trigger an evaluation manually by clicking on Actions, and we'll say Reevaluate. This will kick off the evaluation of that role, and we should then see the resource appear under the non-compliant. So as we see here, our new resource that was just recently deployed with our EC2, our security group, was detected by our AWS Config rule, and it marked it as a non-compliant. If we click on this resource, it then will show us details about our resource. It'll show you the resource name, which was the security group we just created. And it'll also show us the roles that are currently attached to this resource. Now, one thing that AWS Config does provide you with the roles, so we go back to our roles, and we'll click on the role again, is whenever it detects a resource that's in a non-compliant state, we can then implement what AWS Config rules have, which is called remediation actions. Remediation actions allow you to use SSM documents that allows you to take action against that resource to put them back into a desired configuration state to keep them in compliance. So to enable remediation action for this role, we can click up on the top where it says Actions and click on Manage Remediation. This will then provide us the screen where we can actually enable remediation actions for this specific config role. You have two options when you enable remediation actions. You have the option to set it to be an automatic remediation. What this is going to do is the moment it detects a resource in a non-compliant state, it's going to trigger this remediation action automatically for you to put it back into a desired configuration state. For this lab, we're going to leave it as a manual remediation. By leaving it as a manual remediation, you have to then, within the config role, select the resource that is in a non-compliant state and manually trigger the remediation. The next area is you want to go ahead and select what remediation action you want to choose to put this specific resource into a compliant state. If you click on your drop-down list, you're provided a wide list of different remediation actions. These remediation actions utilize AWS SSM documents, automation documents, to do the remediation actions to put them back into a desired state. So for this one, we're going to go ahead and utilize a remediation action that's called AWS Disable Public Access for Security Group. What this remediation action, it'll trigger an SSM automation document that will then go into the security group that was marked as non-compliant and remove all public access rules for that specific port. So we're going to go ahead and select that remediation action. And then down below, you then want to then pass the resource ID to one of the parameters for that automation document. So we'll go ahead and select the drop-down list and we'll choose it to be group ID. What it's going to be doing here, it's going to pass the resource ID of that resource that was in a non-compliant state to the group ID parameter for that automation document. We'll go ahead and click on Save Changes. And then now our remediation action is set. So we see it here, remediation action and the automation document that was defined. So let's go ahead and take a look at this resource. So we'll click on the resource. Up on the top, you have a button that says Manage Resource. This will open a new tab for you. If we look at inbound roles, we can see that the resource does have an inbound role of port 22 open publicly to the internet. So this is the reason why the resource was marked non-compliant with that role evaluation. Now going back to AWS Config, we can then go back to the role and we'll see how remediation actions will be able to then put this specific resource into a compliant state. So by triggering the remediation action, we'll go ahead and select the resource. that's in a non-compliant, and we'll click remediate. This is then going to kick off that SSM automation document that will then run against that security group and put it back into a compliant state by removing those public access rules within the security group. We see action executed successfully. So let's go back into our other tab here that we had the security group open. This is what we saw before. So now let's go ahead and refresh. And as we see, our remediation action worked. That public access rule is no longer within our security group. So the remediation action basically triggered the action where it now put that resource into a desired configuration state of not having those public access rules. Therefore, when AWS Config now reevaluates the security group, it will then put it back into a compliant state. So let's go ahead and trigger another reevaluation. And we'll see this resource going into a compliant state. As we can see, when we refresh, now the resource is no longer in a non-compliant state. If I look at our compliance, we now see that security group where that remediation action was successfully triggered. And now the rule reevaluated that resource and now is marking it as compliant. Another thing I wanted to mention to you when it comes to the resource is if we click the resource, up at the top, we have a resource timeline. The resource timeline is going to allow us to see a configuration history of our resource. So let's go ahead and click on resource timeline. So if we look under our resource timeline, we see the configuration history of our security group. So here we see some configuration changes, we see rule compliance, and also we see CloudTrail event changes too as well. This is all supported within our resource timeline. It will put in there 3 types of events: our configuration events, compliance events, and CloudTrail events. So within our security group here, we have 2 configuration changes. Notice here, this one is the one that it's empty. This is basically when that resource was created. And then up above here, we see a configuration change where it went from one area configuration now to another configuration within that resource. Then we see a rule compliance where then when it was reevaluated, it marked that security group against this AWS config rule to be non-compliant. And then when we trigger that remediation action, we see another configuration change where it then took the configuration of that rule, having that public access rule with port 22 to be changed to now not including that. We then see another event type within our timeline that it then reevaluated the rule and put that rule for that specific resource back into a compliant state. So the resource timeline is a great resource where we can look at the configuration history of our AWS resource, or also within our application, as far as how did the configuration change over time? How was our configuration state? How was our rule evaluation? And it also allows us to then, additionally, if we look at our configuration change, we can click on View Full Record. And this will also show us any relationships this specific security group has. For an example, this security group is tied to a VPC, which is tied to a specific Elastic network interface, which is also attached to a specific EC2 instance. So the resource timeline is a great resource to help us track configuration history against our resource. So we were able to see within this lab how we can utilize AWS Config managed rules when managing our infrastructure within AWS, and also help achieve operational excellency when it comes to our configuration states and our compliance and tracking and managing specific configuration changes within our AWS infrastructure. Now we're going to look at another area of AWS Config that will help us and keep compliance for our configuration within our AWS resources. And these are AWS Config Conformance Packs. So we click on AWS Config Conformance Packs. And what AWS Config Conformance Packs are, AWS Config Conformance Packs are a group of config rules that are deployed within AWS Config, but these config rules are immutable, meaning that you cannot make any changes to these config rules. When they are deployed, they will be grayed out where you can't make any changes or modify these config rules. To deploy a conformance pack, you can click on Deploy Conformance Pack. You're then presented with an area where you can use a sample template or upload an existing custom conformance pack that you have created. And this is created within a YAML format. And we can define all the AWS config rules that we want to define that's going to be grouped within this conformance pack, and also any remediation actions we also would like to take within those config rules. We do provide a variety of sample templates that encompass many different operational best practices when it comes to workloads within our AWS infrastructure. For example, the operational best practices for Amazon S3. We have also sample templates that discuss operational best practices for compliance frameworks such as CIS, NIST, HIPAA, and so forth. These are then provided to provide us a good sample template that we can use as a starting point to achieve operational best practices for specific AWS services or specific frameworks. If you notice down below, you also have a link to our documentation where it then outlines the various conformance packs that we have listed here, and also point you to our GitHub repository where you can actually see the actual YAML code where you can take and then customize your own conformance pack. For this exercise, we're actually going to use one of these conformance packs that we took in regards to our S3, our operational best practices for S3. So we're going to go ahead and upload the template that was provided for us in our workshop. And we'll choose Upload a Template. We'll choose a file. We'll select our operational best practice for Amazon S3 with remediation. We'll open it. And this custom conformance pack is going to incorporate all the AWS config rules related to operational best practices for Amazon S3. But additionally, it's going to define some remediation actions to take into effect when it detects these specific resources in a non-compliant state. We're then going to go ahead and click Next. So we're now going to give it the conformance pack name. And for the name, we're going to go ahead and put in there operational best practices for Amazon S3 with remediation. We're then going to click Add Parameter, and we're going to add the parameter called S3 bucket name for enabling logging. The value, we're going to go ahead and get this value from our CloudFormation template that was deployed in the beginning of this demo. So we'll go over to CloudFormation, and we'll open that up into a new tab. And we'll click on the stack that was deployed, and we'll go over to Resources. And we're going to grab the name of the resource for the S3 logging bucket. So we're going to go ahead and select this and copy it. And we'll go back to our config console. And we're going to go ahead and paste the value there. We'll click Next. And then we'll click Deploy Conformance Pack. The conformance pack will then get deployed, which is going to deploy the AWS config rules that were bundled with this conformance pack together by setting also the remediations. So we'll go ahead and let this conformance pack deploy. All right, our conformance pack was deployed. We see that it was completed. And now we go ahead and click on the actual conformance pack. we'll see the various AWS config rules that were deployed together with this conformance pack and the associated remediation actions. One in particular of these rules we'll go ahead and take a look at is the S3 bucket server-side encryption enabled. This rule is then evaluating, making sure that all our S3 buckets that are deployed are together implementing the best practice of enabling server-side encryption. So if we click on this rule, it's then going to show us the resources that are currently in a non-compliant state. What we'll go ahead and do is we're going to go ahead and go to S3 and create a bucket, and we'll see how this conformance pack together with the rule that's bundled in there will then evaluate the new resource that we created and then trigger the remediation action for that resource. So we're going to go over to S3. And we're going to create a new bucket. And we're going to create a name that's unique to our environment. So we'll go ahead and call it Workshop Demo. And then give it a unique number. This way it's unique. So I'm just going to go ahead and put a random 4-digit number. And then we'll go ahead and look at the various settings that this S3 bucket is going to be set. We'll leave everything default. If you notice, the default encryption, server-side encryption, is set by default to be disabled. By doing that, it should then trigger the rule evaluation of that rule where it's checking if server-side encryption is enabled. So in this particular case, it's not enabled, so it should mark this resource as non-compliant. We'll go ahead and click on Create Bucket. And now we'll go back to our AWS Config console. All right, now we're going to go ahead and click on Conformance Packs. And we'll click on the conformance pack we recently deployed. And we will go ahead and click on the config rule that is evaluating for server-side encryption enabled. So for this rule, we'll go ahead and then trigger a reevaluation. This way it picks up that new AWS resource, S3 bucket that we just created. So we'll give it a little bit for it to evaluate the rule and put the S3 bucket on the non-compliant list. All right, as you see, we have our new S3 bucket, our workshop demo, the name of the bucket. It was marked in a non-compliant state. It's then going to go ahead and then should trigger the remediation action and then put it back into a compliant state. So let's go ahead and refresh. As we see here, the action execution successfully. It went ahead and triggered that remediation action, which then triggered that SSM document to then go ahead and enable server-side encryption on that S3 bucket. So let's go ahead and do another rule evaluation. And we'll then see that this bucket will then be put back into a compliant state. Go ahead and click refresh. As we can see, the S3 bucket is now no longer under the list of non-compliant. If we go ahead and choose compliant, we'll then see the S3 bucket that we just recently created is now in a compliant state. It launched that remediation action successfully, enabling server-side encryption, which enabled a rule evaluation, a reevaluation of the rule to put it back into a compliant state. So we go back to our conformance packs. So this is a good example of how we can utilize conformance packs to deploy config rules grouped together that are immutable, but also we can also deploy together with these config rules remediation actions. Here we saw a good example how we can implement operational best practices when it comes to S3 to keep our infrastructure within S3 into a desired configuration state according to best practices. We were able to see how when we quickly enabled an S3 bucket that did not have server-side encryption, it automatically detected that configuration state and took a remediation action to enable S3 bucket encryption. So another area that we want to look at that's going to help us have an operational insight to our AWS infrastructure is AWS Config Advanced Queries. So we'll go ahead and click on Advanced Queries. AWS Config Advanced Queries allows us to query our configuration of any active AWS resources we currently have running where AWS Config is recording. For an example, we recently deployed a AWS EC2 instance. Under Advanced Query, we actually have a query which will show us some information related to the EC2 instance. So we'll go ahead and type in EC2 here. And in here, we see some of the various advanced queries, sample queries we have related to EC2 instances. So let's take a look at this one that's called EC2 instance by type. If we select it, it's automatically going to put in the sample query for the specific query to display all our EC2 instances by a specific type. So the EC2 instance that we recently deployed was a T3 small. So we're going to go to change this to T3 small. And in order to run this query, we'll go ahead and click on Run. If you notice down below, it then outputs the information. Here we're able to query against a resource and bring back various configuration information related to this AWS resource that AWS Config is currently tracking. So in here we got the resource ID, the resource type, the instant type, if it had any tags enabled to it, which availability zone it was deployed to. So we can see how Advanced Query can give us that operational insight to our configuration state with running AWS resources currently on our account. Let's go ahead and take a look at another Advanced Query sample when it comes to relationships. Let's say, for an example, we want to see all resources related to a specific instance. So we'll go ahead and paste a sample query there. And in here, we're basically going to select all the attributes where the relationships include a specific resource ID. And so for that resource ID, we're going to grab this resource ID of our instance, and we're going to go ahead and paste it there. So this should then return to us all the resources that currently have a relationship with this instance. So we'll run it. And if we notice down below, it's showing us the various resources that are related to this specific instance. Similarly, how we saw in our AWS config resource timeline, where it showed us relationships, we have the same relationships here, which shows us the ENI, the instance that this specific resource, and the security group. Also has some of our SSM managed inventory that is pulling application inventory as well from for this specific instance. So let's go ahead and take a look at another query that will give us an example of how we can use Advanced Query to also group together specific information and aggregate on specific information. So we're going to go ahead and look at this query here. This query here is basically going to show us a grouping, an aggregation of our compliance type. And we're going to go ahead and filter it by specific resource compliance. And we'll go ahead and run that query. And we see the results here. Now it's showing us a group of compliant and non-compliant and how many of those resources we have. So we see here we have 7 non-compliant resources and 2 compliant resources. Again, another example on how we can leverage Advanced Query to get operational insight to our running AWS resources we currently have within our region. So let's take an example of other areas. Let's say, for an example, you want to see within your account any EBS volumes that are currently not being in use. With advanced query, we can also utilize another sample query that allows us to select the various properties against a resource of our EC2 volume and look for a specific configuration state. And this one here, it's basically wants to return any EC2 volume, EBS volume that's currently not in use. So I'll go ahead and run this query. And here it shows I do have one volume that is currently not in use, meaning that's not attached to a specific EC2 instance, and gives us different information related to this volume. Additionally, with any of these queries that we define within Advanced Query, we have the option here to export as, and you can export this information as a JSON or CSV file. You also have the option, if you want to, go ahead and save this query where you can later then run it and be listed within your list of queries within Advanced Query. You can click on Save As, give it a name, and then click Save. So this gives us an example on how we can use, again, Advanced Query to get that operational insight to our configuration state within our AWS resources. Another method we can use these Advanced Query is also via the CLI. So let me show you real quickly how we can use the CLI to return information from Advanced Query via our CLI. So for this, we're going to go ahead and use Cloud Shell. So we'll go ahead and open up Cloud Shell. So Cloud Shell has loaded and we're in our terminal. And so what we're going to do is we're going to give you an example how you can use the AWS CLI to also query your resources within using AWS Config Advanced Query to output some information in regards to the configuration state of our resources. So I'm going to go ahead and paste the command that's provided in the workshop. This is going to query our EC2 instances, and it should output it in a YAML format. As you can see, the information was outputted. It gave us the resource ID as one of the results. So it just gives you an example how also you can further leverage Advanced Query not only within the console, but you could also do the same thing via the CLI command and output it to YAML. Or you can then further use different scripts to pull this information that AWS Config is tracking within your environment when it comes to your configuration state, your infrastructure changes within AWS. So we'll go back to config. So as we saw within this workshop, we were able to see how we can use AWS Config to manage and track our infrastructure changes, and also how AWS Config could also track application changes too as well. How AWS Config utilizes AWS Config rules to manage a configuration state for our resources. We were able to go through an exercise on how we used a manage config rule to track our changes to our security groups and make those security groups in a non-compliant state if it had public access rules to the internet on specific ports. We then were able to see how we can utilize SSM automation documents together with AWS Config to remediate those resources that were in a non-compliant state to put them back in a desired configuration state. We then were able to see how we could also utilize AWS conformance packs, how we were able to create a conformance pack that included various config rules in regards to S3 operational best practices. We also saw how we can build our custom conformance pack with remediation actions tied to those config rules. And we saw how we were able to create an S3 bucket, and automatically those remediation actions took into place to put our S3 bucket back into a desired configuration state. We then were able to see how we can utilize Advanced Query to gain operational insight to our active configuration state of our resources running within AWS, within our AWS environment. So now that we're finished with our workshop, our next step is now we're going to go and clean up all these resources that we provision during our workshop. So the first one we want to go ahead and do is we want to go ahead and first terminate that EC2 instance that we deployed when we started the workshop. So we'll go over to EC2. And we'll click on Instances. We'll select the EC2 instance. And we'll click Instance State and choose Terminate Instance. We'll click Terminate. This will then start shutting down and terminate the instance. We'll give it a little bit for it to completely terminate before we proceed to the next step. So our instance is now terminated. So once our instance is terminated, our next step, we want to go over to security groups. And we want to go ahead and delete that security group that was provisioned when we deployed our EC2 instance. So we're going to select the workshop security group that was created. We're going to click on Actions, scroll down, and we're going to choose Delete Security Groups. We'll go ahead and confirm and click Delete. Our security group is now deleted. Now we're going to go over to AWS Config. And we're going to go first to conformance packs. And we're going to delete the conformance pack that we deployed in regards to our operational best practices for Amazon S3. We're going to select the conformance pack, click Actions, and click Delete. We'll then type Delete and click Delete. This will then start the process of deleting the conformance pack that was deployed within AWS Config, and so we'll give it a couple of moments for it to delete. So we see now our conformance pack has then been deleted. So the next area we want to go ahead and remove is AWS Config rules. And we're going to remove the rule that we initially created to restrict common ports. But before we can delete this rule, we want to first remove the remediation action that is currently tied to this config rule. To do this, we'll click on the rule. And under remediation actions, we'll click Delete. We'll then type in Delete and click Delete. Our remediation action is now removed from the config rule. So now we'll then click on Actions and choose Delete Rule. We'll type in Delete and click Delete. Our config rule will then be queued up to be deleted within AWS Config. The next area we want to go ahead and do is under Settings within AWS Config. We want to go ahead and turn off the AWS Config recorder so it no longer will start recording any configuration changes of new resources that are new or updated resources within our AWS environment. To do this, we'll go ahead and click on Edit, and we'll uncheck the checkbox for Enable Recording. And then we'll click Save. Our recording is now turned off. Now to delete the actual recorder, we'll need to go into Cloud Shell, and we'll use the AWS CLI to delete the default recorder. So we'll open up Cloud Shell. Click the default close. We're in our terminal, and now we're going to paste the CLI command to delete the default recorder. The recorder is now deleted. We'll go back to config to confirm that it has now been deleted. So we're going back to AWS Config. And we now see that AWS Config is now requesting to be set up again. So this lets us know that all the resources within AWS Config recorder is now deleted and no longer recording any additional information of resources being changed within your AWS account. So the next area we want to go ahead and clean up is our S3 buckets. So we'll go over to S3. And we're first going to delete the S3 bucket that we created for the conformance pack called workshop demo, and then the couple of digits that you put into the name to me unique. So we'll select that bucket and then click delete. Select the bucket name and type it to confirm and click delete bucket. We'll then also delete the config bucket that was created when we initially set up AWS Config. We'll first select that bucket and choose empty. And we'll type in there permanently delete and hit empty. Now up on the top, we can go ahead and click delete bucket and also put in the name of the bucket and click delete bucket. The next bucket we want to go ahead and clean out is the S3 bucket that was used for server-side logging. So we'll select the S3 server-side logging bucket and click empty and type in permanently delete and click empty. Now we're going to go over to our CloudFormation. And we're going to delete the stack that was deployed at the beginning of this workshop. We'll select the stack and click delete and click delete stack. So our CloudFormation stack has been deleted. So within this workshop, we were able to see how we can utilize AWS Config to manage and track our configuration changes for our AWS resources. By utilizing AWS Config, we're able to track these changes and be able to run successfully our operational excellent workloads. We do thank everybody for attending today's workshop, and please let us know if you have any additional questions.